Alright, so chapter 4, we're getting into some function notation and we move into solving some equations, so kind of a big chapter for us, but get these notes written down, a relation. It's just two variables, so I could collect your ages and heights and write them as ordered pairs. That's a relation. So it's just some numbers in parentheses, ordered pairs written down. Function, relationship between two variables where for each x there's only one y. The whole one input can only have one output. For every input there's exactly one output, however you say it. Talk about the vertical line test, which is over there. U-shaped graph here. Draw a vertical line, it hits, it tells you that x goes to that y. That's only happening once. We'll talk more about it. This sideways parabola, if you draw a vertical line, it's hitting twice. That's not a function. And then at the end here, function notation. Notice what they're saying. It's the name of the function. So we're calling it f. That's the standard notation. If you were doing like throw a ball in the air problem, you might use h to name the height. So it c for cost functions. Stuff like that. They're telling you x is the input variable. This is big right here. It's read f of x, not f. This is not f times x. It's not multiplication parentheses. It's function notation, so that's a little bit different. So get those copied down. And we'll talk about them in a second. So the vertical line test will be the easiest way for you guys to tell whether something is a function or not a function. If it hits the graph once, function. Hits twice, not a function. So investigation textbook, page 180. So we have a bunch of different situations up here. Think in terms of inputs and outputs. For every input, there can only be one output. So try to figure out these 6 situations. What this is talking about over here, if you're confused, you could plot these points. You could plot the points just on a quick sketch and see if it's a function or not. So do that with somebody sitting near you. Just answer yes or no. Alright, vertical lines. If I draw one there, if I draw one there, I actually miss both graphs. So this one is a yes. Wherever you draw your vertical line, you're only hitting it once. Same thing on this one. But here, doesn't matter. Once I do one vertical line, it hits twice. We say no. For whatever reason, sometimes the D, E, and F get a little bit confusing for students. Input. For every input, there can only be one output. So look at this input. How many outputs does it have? 1. How many outputs does that have? 1. The arrow says it goes to 1. That's good. How many outputs does this one have? 1. That's good.
1.
Good. 1. Good. How many? So this is a yes. How many outputs does the 1 have?
1.
We're good. 2? 3? 4. So that's good, right? That works. So that is a function. If you graphed it, all it is telling you is that for every input, they're lining up across, it's like a horizontal line. So just because the input, they all go to the same output, I think that's where students get confused. But just stop and think. How many outputs is it telling me that the 1 has? It only has 1 output. So where's the problem over here?
Like, there are actually 2 arrows from 1 and 2 of them on 3, so I'd say that one is a no.
Yeah.
That's a no.
The 1 and the 3 both go to 2 different outputs. So this whole rule is if I kind of split the class in half and I said, okay, plug in 1, half of you get 1, half of you get 3, and then we have this huge argument in math, who's right or who's wrong. Functions, 1 input, 1 answer only. So this is a big fat no. Okay, consider these functions. Notice that we're changing quote unquote the name of the function, f, g, h. So you have to pay attention to the different letters. So for this one, they want you to do what?
Find f6.
F of 6. So what does that mean? You take 6 and plug it into f. So f of 6 is 2 times 6 squared plus 3 times 6, correct? I take that 6 and I plug it in there and I plug it in there. What is 6 squared? Times 2?
72.
72. What's 3 times 6? 18, and I'm getting 90. Now, just to show you, you could do the same thing if it was a y equals equation. You do all your same work. So what really is the only advantage to using function notation? F of 6 equals 90 and y equals 90. What's really the only advantage to function notation? F of 6 equals 90. What's my input?
6.
What's my output?
90. You can see both parts.
Somebody tells you y equals 90, then you would say, what's the input? And you really don't know, right? You'd have to find it up earlier in the problem. That's the only advantage. So what I want you to do is somebody sitting near you again, pay attention to the letters they're giving you and the numbers so you can put them in the correct locations. Simplify your answers. Do that now. Alright, so as you're wrapping up those answers, go ahead and check them here. 90, 2, 6, 10, 6, and 2, I believe, over there.